and welcome back. Now today you can see on my workbench a number of various forms of ESP8266s. We got these ones which are nicely written on the back here. They're Node MCUs V3s, and they are probably the easiest to program because you don't need to press any reset and flash buttons like you do with, say, the ESP Arduino or the D1 WeMust D1 or anything like that. It just does it all for you, which is why I've got this mounted on a nice little friendly Node MCU base, where we can power it up and let it get on with it. Then we have the hard path, as it might be called, because we're going to be looking at this bare naked ESP8266 that's going to be mounted on this breadboard, and I'll show you how to flash the code for one and then run it after having put it into deep sleep. But it's all doable and not a problem. But the very first thing we need to do is just take a step backwards from this, because if you watched my Arduino deep sleep videos, I think there were 2 of those, when you come to this one you think, what? That's how it works when it comes out of deep sleep? You gotta be kidding me. Nope. The ATmel chips, as used in the Arduino Uno and the Nano and all that, do it, in my view, as you'd expect. These ones, they don't. But let's have a look how they do it and discuss the merits and, well, the cons of doing it their way. So let's think about what happens in the Arduino, that is the ATmega328P chips. As it comes into the setup, it just does whatever it needs to do, setting things up, initializing, I don't know, reading things back from SD card or anything like that you might want to do, and then it hits the loop and it whizzes around the loop any number of times. So it does this and comes back in again, because perhaps you're unaware that there is in fact a program that controls all this that we don't see as part of the Arduino, but sometimes you can catch a glimpse of it, and what it says is go and do the setup and then go and do the loop forever. So that's how the loop keeps getting executed. Anyway, so the Arduino is whizzing around this loop, but somewhere in here we say go to sleep please, right? Well, there's a condition that's been met or something, and we say at this point here sleep. Now, as you saw in my previous videos, this is a watchdog timer sleep. Normally you can do it on an interrupt as well, but let's assuming it's on a watchdog timer. When this watchdog timer expires, this here comes into being, this sleep ISR. It's not actually called that, there's a special name. You'll have to watch the video to find out what it is. And it comes in here, and the first thing is basically you've woken up, right? The timer's expired, and we say, timer, watchdog timer, yes, you're about to reset my machine, aren't you? Don't do that. I'll kill the timer. I don't want to know. We then end the sleep ISR, and control returns back to the exact point of where we were before the sleep was invoked. Did I say before? Sleep at the exact point after the sleep, the very next statement basically. And it continues on that loop with all the variables and everything else that we've set in here, and indeed set in the setup. They've all been retained, and that's it. No problem at all. Now, that's the ATmega328, and it has to be the P version. That's the pico power. That's anyone that does this properly. Okay. So, okay, that's then the Arduino. How does the ESP8266 do this? I'm glad you asked that, because it's a little bit different. So this is now for the ESP8266- whatever, right? They all work pretty much the same. Right. So we come into the setup routine, initialize whatever it is you need to initialize, and then you just carry on. You don't normally go into the loop because the concept is not there anymore. Yes, there is a loop function. You can use it if you want to, and if your logic dictates you go around the loop a few times before going into sleep, that's okay. But normally you do it all in the setup, and at some point in that setup you'd say, now I want to go into sleep. And we are talking deep sleep here. Okay, so we go into sleep, and then after a certain number of microseconds we wake up, and then what happens? So we've gone into sleep, we've woken up, and then we execute the very... No we don't. We come back in at the top here. So after a sleep we come back in to the very top, which is like, what? Who designed this chip? And basically it really is a bit of a hash in my view. I mean, yeah, I'm sure the people who designed the chip are much more intelligent than me, but not to have a proper sleep resume mode, I just don't get it. What happens is, having come into the sleep mode again, you can then say, why am I here? Have I just woken up from deep sleep? Or is this the very first time I'm through here? Well, okay, let's assume that there's a nice easy mechanism for determining why you're here. Is it because it's the first time? Power up. So that's probably one good reason, isn't it? Power up. Somebody's pressed the reset button. That's not going to work. And then, of course, there's deep sleep. Wake up. Now, there is a way of determining which one of these it is. So we come into here, and our logic in here now has to say, this is not my first time through, therefore I won't do all the setup that I would have done. I'll just carry on a little bit, except of course that all the variables in here haven't been set now. You really have to do the setup from scratch. That means, especially with an ESP8266, it means connecting up to Wi-Fi, for example, doesn't it? That's one of the things you probably want to do. So within the sleep, even if you know why you're here, you have to be very careful in what you're doing here in terms of power up or deep sleep, and go, which bits do I need to do? Now, one of the tricks that people use for ESP8266 is to say, when I connect to Wi-Fi, I'm going to use a fixed IP address. Do not use DHCP, because that takes far longer to establish a connection. So it's a fixed IP address, and then you come along, sort out a bit of your logic, and then carry on with the main part of your routine again. It's nowhere near as nice as the Arduino ATmega328P version, because there's some convoluted logic you have to put into here, and well, that's the way it is. I must admit, when I first saw this and realised how it was all going to work, I thought, you just got to be kidding me. It's just, I mean, we could do this, could we not, with an Arduino? We could just reset the Arduino, set one of the GPIO pins high or low or whatever, so that the Arduino can go, why am I here? Read that GPIO pin. Oh, I've woken up from deep sleep. I'll go and do all this. It's pretty unsophisticated, really. So there we are. That's the way it is, though. And Espressif chose this particular chip. That's the one there on screen now. That obviously doesn't have this resume from sleep particularly well controlled. And given that this is such a high power consumption chip, it's a shame, really. But there we are. That's the way it is. So that's how it works. So let's go and fire up that board. This one here, in fact. We're going to fire this up. Even if we put this one to sleep, that chip might be into deep sleep, but nothing else would be. So yeah, but it's a good thing to develop on, and then put it onto that bare one, which is coming up later in the video. So let's do that next. Right, there are a couple of interesting things then about the Node MCU, or rather ESP8266s generally. Okay, first of all, if we look at, I've connected this up and I'm powering up this dev board with a separate 12-volt supply. And at the moment it's taking, let's have a look, if I go onto the camera over there. Anyway, we're picking up 41 milliamps there, and it's waiting for me to do something at the moment. Okay, now if we look at the ports window on, this is Windows, I don't quite know how it'd look on Mac. But if I bring up my ports, you can see here, this is the port that we're on. However, if I disconnect the external 12 volt supply on here, you might have heard a noise there, and it disappears. Basically, this is not being supplied sufficiently by the USB socket alone. Even though the little light's on down there, it doesn't help. So that has to be plugged in, You just heard the noise. There we are, and it's back again. Fine. So this is one of the things I found with the ESP8266s. It needs an auxiliary power supply. Now maybe my hub should be powered. It's not. But even when I tried one, I tried a little. Right, I tried this one here. I tried a D-Link one, and I powered it, but it made absolutely no difference. It just didn't want to know until I powered this externally, if you like. It didn't spring into life at all, which is what I suspect is a lot of people who say they can't get it to work have that problem. It might just about load up and go into deep sleep, but when it comes back out, it just hangs basically. So what? So you have to be aware of that. Okay, just a heads up. Do power it sufficiently. This is running on 12 volts. I could put 9 in there; it'd still be okay, but it does need an extra power supply. Right. Let's get rid of the ports and go to the code window. Right, so I've reset it and it's waiting for a character, so I'll just press send. There we are, and it's going into sleep every... Oh, that's a lot quicker than I thought actually. That's going to sleep, and what's it doing? Let me have a quick look. It should be sleeping for 5 seconds. Oh, I know what's happened. Haha. This is an old sketch. It's not the sketch that I've actually got on my code window as we speak. So it's not this code here at the background that you can see, because if you see, I've got it as ESP deep sleep 5 seconds. What I was doing on this particular bit of code was sleeping it for 100 milliseconds just to see how well it worked and how many times I could get it to come out of deep sleep. And well, it just went for thousands, tens, hundreds of thousands of times without any issue whatsoever. Now, as you can see, we didn't actually have to press anything. I've connected up the reset to GPIO 16, which is what you have to do. So basically, at the end of deep sleep, the timer, the RTC on board here, brings GPIO 16 low, which means if it's connected to the RTC, it's the same as giving it a reset pulse, and off it goes. And of course it does know whether it's woken up from a deep sleep or not. And I'll cover that in the code in the next bit of the video. Once we've gone through the naked video, I'll show you exactly how that's done. But the key, of course, is that we do know that it is a deep sleep wake up. So what it's saying here is, look, deep sleep wake up. So it does know that it's been deep slept. Deep slept, is that even an expression? And it's not somebody basically pressing the reset. In fact, while it's sleeping, we can't do it because it's too quick here, but while it's sleeping, if you were to press the reset, it would actually wake up from deep sleep and go, ah, I've been in deep sleep, that's why I've woken up. It would not say you've pressed the reset and start again. Okay, so just bear that in mind if you're testing a program. Cool. Okay, so that's trundling away, and it will just keep going into deep sleep and back out again. Now, if we go to the meter, the multimeter, and see how much current we're taking. Now, as I say, we've got the whole board here that we're looking at, but it's okay. Let me move that aside. There we are. So what it is, it's saying 40 milliamps roughly when it's just sort of running, and when it's into sleep mode, it does drop to about, well, it says 4 there, doesn't it? But it's all a bit quick. So let's upload the other sketch that I just showed you. Go over to the code window. Right, and I'm going to upload this. Now, the good thing, as I say, about this board is that you don't have to do anything. You just leave it like that and off it goes. So let's upload and see what happens. Right, that's uploaded, no trouble at all, just left it exactly the same way as it is now, and it's come up on screen saying send any character. So what it's done, of course, is read the reason why it was started and has determined that it was an external system that's to reset it, which basically means power up, or even the reset button. So if we were to press the reset button now, yes, it would know that it's an external system. There we are, let's done it again. And now we've got 5 seconds, so this will be the interesting bit now. So we'll do this, so it goes, yeah, first time only. Then it's sleeping for 5 seconds, fine. Now if I press reset while it's sleeping, look, it says deep sleep wake up. So it doesn't reset in the usual manner if you reset it while it's deep sleeping. Now if I can catch it Oh, we'll have to wait another 5. The minute this comes out of sleeping, I'm going to press reset. That's instant. Now, there are external systems that did know, because it wasn't in deep sleep anymore. Obviously the system itself, the chip itself, had cleared the flag that says I've woken up out of deep sleep. I'll then press reset and it goes, oh look, it must be an external system. There are many reasons why it's in that setup routine, but the ones we're interested in is, well, anything that says deep sleep or not, really. So there we are, that's that. I mean, it's all pretty simple, isn't it? Now, if you get, if you haven't got one of these boards, and well, from what we've already seen, I would say it's almost essential if you want to play with these, because you need to power it up somehow, don't you? So I'd say get one, because otherwise you're just going to be faffing about. But if you, even if you didn't, you might want to do it like this, which is 2 breadboards put. So there's one breadboard, that bit, and then there's another one. They click together, where there's little tabs and things, and then you straddle it over 2 of the power supply things, and don't use those as power. Well, you could use those as power, but I mean, because it's covering most of it, you might just want to put the power onto here, fine. But then you've got lots of room, haven't you, for other connections. That's one way of doing it, because they are a very wide board, and they do take a lot of pins up otherwise. That would never work on a single board, because I think it actually goes from the top set of pins to the bottom, or maybe one up, or whatever, it takes too many. But 2 boards like that works rather nicely, actually. But you still have to power this with something other than just the USB. Right. So what we've covered so far then is that this particular module loads fine without you doing anything. So it's a good module with which to start. It will load the firmware, the flash, the program, the sketch onto it, no trouble at all, and you can run it without making any adjustments. You don't have to connect anything to anything. Okay, so that's, for a beginner, this is a really good board to get. To actually use in terms of sleep mode, it's not ideal, is it? Because you've got LED, you've got that one there. There's a couple more somewhere that occasionally come up, but perhaps not in this sketch. Maybe we're safe. That one I'm driving, but even as it starts up, you get a very short pulse first. There we are. You see that? Do you want to see that again? So when it wakes up after 5 seconds, you see the very short pulse, and then the full 500 milliseconds, which is us. So that short one, that one, is being generated by this, probably trying to attach to a network or something. And as we said, the actual current, 4.3 milliamps in sleep mode, 40-ish when it's running. Now, yeah, that's a saving, and if you just wanted to run it for a few hours, that would be enough. But not if you want to run it for weeks on end. That's when you need the bare naked ESP8266 12E or something like it. You can use 01 and 01. You can use any of the ESP range really, but you do need to have it on a separate board. Let's talk about that next. So this is the bare ESP8266 12E module here. Now I don't want to muck about with it too much, because as you can see, it's a little bit of a rat's nest, but believe me, these connections are simple, and I will be giving you a proper diagram, and some of these connections are only used at boot time, or rather at flash time, and some at run time. So the other boot, there's 2 ways of booting this, one into ready to receive a new program, and another way, the usual way, which is just to run the embedded program. Now I have got a diagram already prepared, but I'll probably be putting that either into Paint or something like that, Paint Shop Pro or something of that ilk. By the end of this video, I'll certainly talk it through in much more detail. Now, the reason why it's all a bit delicate at the moment is because this is, as I say, a bare 12E running in sleep mode and waking up every now and again. So I'm going to clear the debug window. This is all run from the Arduino IDE, by the way. So if I bring up the debug window, and it's bare at the moment, as you can see, and this little button down here, this one here, is a reset button that will, well, it'll reset the 12E, won't it? So let's just press that. Now the interesting thing about this, of course, that it says, well, first of all, I'm waking up from deep sleep, and this is iteration 12, and now it's going back into sleep mode. Now I've got it at the moment sleeping for 5 minutes, 300 seconds. So this is the meter, and that's currently set to milliamperes, as you can see. But because it's now sleeping, I can now switch that to microamps. So now the current is indeed flowing through that meter. Now you can see it's running at 73 microamps. According to my notes, it runs from anything from 46 microamps to, well, 73 is the highest I think I've ever had it, actually. 73. No particular reason why it runs at one setting compared to another. Just seems a little bit random, really. Oh look, there we are. It just went down to 68, didn't it? So sleeping, this is fine, and that's the lowest I can get it down to. I can't get it down any lower than that, and this is an absolute bare board. Well, I say it's a bare board, as we can see at the front there. The bare board is soldered onto a backing board, and that backing board is simply a breadboard friendly way of doing it, so it would fit into a row of header pins or something like that, and also your breadboard. And the only thing on here is a couple of 10k resistors. There's one there, and there's one, oh I don't know, somewhere else probably. Is that it down there? Whatever. And I guess that's just to enable the chip to boot up or something. Whatever. That's all it is. It's absolutely bare. There's no LEDs on there apart from the blue one, of course, on the actual device itself. Okay, so we've proven then it does go back to sleep and it does wake up. Well, it wakes up when I press the reset button, which is an anomaly in itself. Basically, if it's in deep sleep mode, this is only the ESP8266. I haven't tried it with the Arduino. If it's in deep sleep mode and you press the reset button, it wakes up and goes, ah, I was in deep sleep mode, therefore I must be in that sort of, wake up cycle. So if you have got one of these built into a real product and you press the reset hoping it's going to reset it from the beginning, it won't. You'd have to disconnect the power. Now if we do disconnect the power, which we can do quite easily, just keep watching that debug window. So that's this one here. So we can disconnect, and now if I reconnect, now what it's saying down here now in the external, it goes, well look, the reason for the reset was an external system. Something reset me, in other words, properly. And yes, that was true, because it was me unplugging it. So now we've got to send any characters to begin, so I can just send any old thing here, because I've got the new line property set. So it's just, if I press send on an empty string here to send the new line, off it goes, and it says first time only, it initializes a loop count, and it goes back to sleep. Cool. I'll show you the code in a minute, but there's just something else I've got to show you first. So I'll show you how we can upload that sketch onto that device just by connecting a couple of wires up. Right, this is the code we're running. It's the simple Blink program, slightly modified to make it go into deep sleep. So we'll whiz through this. Basically, we're setting the baud rate at the beginning to 74880, because that seems to be the speed that the ESP itself seems to report when it actually boots up before any code is run at all. So I've kept it the same. Right at the top we've got the built-in LED, which is pin 2 but known as D4. So once again there's a double numbering system on here. So what we're doing here is saying why are we running, and there's a very nice little utility called ESP.getResetReason, and that is of course the key to knowing whether you're starting up for the first time or whether you're coming out of deep sleep. And we just print it to the screen so we know what's happening. Now if we're not waking up from deep sleep, then we well, first of all pause here for the user to send something just so I can demo this properly, but then we're initializing the loop count and writing it away to the real-time clock memory on this device that survives a deep sleep. It will not survive a power down though. That's what we do. Now this here, we're casting the value here to an unsigned integer 32. Now in this particular sketch we don't need to, because I've actually got an unsigned int here. But if you were trying to store anything else, it'll always write away the 2 bytes. size of loop count, that means how many bytes are we taking up, and in this case we're taking up 2. And it is a deep sleep, wake up, then we're just saying go and get me the loop count and print it out what iteration it is, and we'll just increment that a bit later. Now, coming out of a setup, we're going into the loop. We don't have to. All this code could be written in the setup, and indeed many examples are, but they don't have to be. You could be running the setup, then doing a loop of many times before you decided, now I need to go into deep sleep. As long as you remember that, of course, when you wake up, you'll always start again from that setup. So we just flash the LED on and off, and remember the low and high are reversed compared to Arduino's. So low is on and high is off. Update the loop count, write it away exactly the same as before. I'm writing it away at memory location 1. That's because I was using memory location 0 for something else, but I didn't need it at the end of the day. And then just sleeping, and I'm sleeping here for now 5 seconds. Now you can see down here, I've just flashed it actually, but then it started back up again from deep sleep mode because we hadn't killed the power. The real-time clock bit survived that, so when it started up it goes, I've just woken up from deep sleep, which is total nonsense. It hasn't, of course. So I thought I'd just show you the flash mode, make sure it actually works. So we'll make this a little bit bigger here now that you've seen the code, and I'll connect up the power. So the power goes to this one here, and I can say flash by running that. So it shouldn't compile very much because we've just done it. Right, it's trying to go into flash mode now. Here it is. So it's writing away. All the settings, by the way, for the flash, I'll put in the GitHub. But just by clicking on the tools, you can see all the settings here quite easily. Right, that's just back and complete. There we are. So we're done. If we go back to the debug window, so what that's saying is now send any character, which we've seen before, but what the difference now is that we're just going to sleep for 5 seconds. So we'll send that, it says I'm sleeping, and then after 5 seconds, without any jiggery pokery, there it is, it says I'm rebooting, and it's hung. I've probably done something with this meter. Let me just take this meter out of the equation, because that really does muck it up, and we'll be right back. Well, actually I was blaming my meter, which could have been the cause, admittedly, but it wasn't that time. It's because, of course, we've left it in boot mode, haven't we? So GPI 0, it's this wire here. Let me go back to Workbench. So we've put it into boot mode by connecting GPI 0 to ground, so that one can come out. And we've connected GPI 2 to VCC 3.5, so they can come out. Right, so now if I press reset, it should say first time and then come out of sleep as well. Right, so we'll send a character. Right, sleeping, and it should now come out of sleep because we're not going back into boot mode. Here we are. So it's come out of deep sleep wake, here it is, and it's iteration 1, which it is, and then deep sleep wake, and it's iteration 2. And now I've had not this particular one, it's the previous one that you might have seen. It's this one here. That one ran for thousands and thousands, tens of thousands, if not hundreds of thousands of sleep modes without issue whatsoever. Right, I think that's proven that this works. The code that demonstrates this is the simplest in the whole world, because it's the blink program plus the bit that says you know, write to the user memory, so we don't lose that fact. Cool. Okay, let's move on. Right, let's just talk about a couple of other little things that haven't come up in this video. So things we haven't covered in so far. Here's the Wemos D1, and this is an ESP Arduino. Both work in what I can tell is absolutely identical ways. You can upload that code just the same and it will run exactly the same, and these will both go into sleep. But once again, because these boards take so much power anyway, it's almost a pointless exercise. Yes, it will save some power it will, but given that, you know, 5, 10, 20 mil even is being consumed by LEDs on these boards, it's not ideal. Good for developing on again though, but then you would have to transfer it to one of those naked ones to get the real power savings. Now, we mentioned also on both boards, the naked one, this one, and this one, that they needed additional power supplies, and it wouldn't work even when I connected up this lithium ion cell from 3.3. Just would not work, and it wouldn't run just from the power on here. This is an unpowered hub that it went into, but it wouldn't work on that either. So okay, let's talk about this a bit more then. Let's clear the decks and think about the connections from here. So this end goes into your USB cable that goes into your PC or hub or something, and these are the ones that go into your bare naked ESP8266. So here, okay, so on this board you can just about make out that the first pin on the right, well, the left hand side as we're looking at it, is ground. CTS we don't use. Then you got VCC, then you got TX, then RX, and finally over here you got DTR, which we don't use either. So in fact that green one is not being used as part of the ESP. We had to use that as part of the Arduino one, but not here. So there we are, 4 wires. Okay, how does that translate then back down here? So TX on here, which is the orange, goes to the RX on here, pin 2 or second from left, and RX yellow goes to TX, which is the first one on there. That's fine. Ground goes to ground, VCC to VCC. Do make sure you've got this set to 3.3 volts. In fact, it just says 3 volts on it rather than 3.3, but do not set it to 5 volts because you'll immediately cook this. It will not stand that, not even for a split second. So do be very careful. Now I did read somewhere that GPIO 15 is supposed to be connected to ground, but that's tosh, frankly. It didn't make any difference, and I don't see why it would. GPIO 0 needs to be connected to ground when we want to flash it, as does GPIO 2 need to be connected to VCC when we want to flash it. Okay, so to flash it you just connect them in as it shows you here. This will then on power up go into like flash me mode, and that's it. Then it will flash and then it will reboot and it will actually start running at that point. Now at runtime mode, because the timer on the chip sets GPIO 16 low at the end of the timer setting, you know, 5 seconds, 100 milliseconds, whatever, you need to connect that to your reset pin here, which then effectively is the same as you pressing that button, no different at all. It just grounds that reset button for a little bit, a pulse. This springs into life and it restarts, and the only good thing is that the chip itself must use some of that real-time clock memory, because some of those memory locations are reserved for system use, it says. Well, ESP say that, and I'm guessing that's where it stores the information. So when it goes into deep sleep, it must write to that the same as we are, and that's how it knows that it's been in deep sleep. So DTR we're not using, CTS we're not using. That's it. I mean, it's simple but made more complex, because on my setup I had GPIO 2 floating around ready to be connected to VCC and GPIO ready to be connected to ground. But if you take those two away, you've only got 4 wires, haven't you? Okay, that's it. As I say, I'll put this picture either as is or enhanced or whatever up on the GitHub, so you can print it out, which is probably a good thing if you're playing about with this, and all will be well. Okay, that's it then for this video. Hope you enjoyed it. Remember to give me a thumbs up, because YouTube like that when people give thumbs up to videos, lets them know that people are watching it. Put comments, likewise. YouTube like it when people comment on videos, because it means there's a lot of interaction going on. I do try and answer every single comment. And great, I'll thank you for watching this video and see you in the next one. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.